Okay, I'm going to go through the 3NA 2017 EOY paper now. So let's look at the question. So section A, question 1. Diagram below shows a simple pendulum which oscillates between A, B, and C. Explain what is meant by the period of a pendulum. So the period actually is the time taken for one complete oscillation. Okay, so just take note of that. So it's the time taken for one complete oscillation. In this case here, it is from A to C and back to A. Okay, that's one oscillation. So that's for part A. Part B here, it says a student obtains the following values for 20 complete oscillation of pendulum. So 12.6 seconds is for the first set of 20 oscillation. 12.7 is another 20 oscillation. 12.5 is another, 12.6 is another, 12.7 is another. So actually this result is for 20 complete oscillations. So he did 20 complete oscillation 5 times. Okay, so first thing first, let's find the average time for 20 oscillation. Okay, because they asked me to determine the period. If I got 5 sets of readings, which one should I take? Okay, you cannot just take any one of them. You must first find the average for the 20 oscillation. So what to do? 12.6 plus 12.7 plus 12.5 plus 12.6 again plus 12.7. And the whole thing, because it's 5 sets of reading, you divide by 5 to get the average. So what you're going to get is actually 63.1 divided by 5, and you're going to get 12.62 seconds. So the period is for one oscillation, so I need to find the period. What I need to do, period is actually taking 12.62 divided by 20, and you're going to get 0.631 seconds. So 3 significant figures. So the period is 0.631 seconds. State how the period of the pendulum can be increased. Okay, so now period of a pendulum can only be affected by two things. To increase the period, what I need to do first thing is to increase the length of the pendulum. The other way to increase the period is to increase the is to decrease the gravitational field strength. So obviously you can't adjust the gravitational field strength in the lab, right? So there's no way you can do that. So therefore, the only answer for part C is to increase the length of the pendulum. And so you can use more string and stuff. So actually it's about increasing this length over here. So as the length increases, it will increase the period. So that's for question 1. Question 2. The gravitational field strength on Moon's surface is smaller than that on the Earth's surface. A piece of rock is brought from the Moon to the Earth. State whether the following properties decrease, increase, or remain unchanged as a result of the journey. Now, mass is the amount of matter in an object. So the piece of rock, as long as it hasn't shattered into pieces, nothing is chipped off. So the mass of the rock on the Moon and on the Earth actually is the same. So it remained unchanged as it goes from the Moon to the Earth. Now, how about the weight of the rock? We know W equals to mg. If the mass remains unchanged, so m stays constant, the weight of the rock will now be only dependent on the gravitational field strength. So we know the Moon's surface has a smaller gravitational field strength. So G on the Moon is smaller. G on the Earth is greater. So now if I bring the rock from the Moon to Earth, so the G experienced is higher. So W equals to mg. So the weight of the rock will actually increase. Okay, increase as I brought the rock from the Moon to the Earth. Okay. Next, question 3. The figure below shows a simple wave motion. Okay, simple wave motion. Mark in the figure the position of a crest and a trough and label them clearly. Label them clearly. So the crest is the highest point. So this is a crest. So you pick any of the highest point, that's fine. Trough is over here. So it's the lowest point of the graph, of the wave. Next, part B. The speed of radio wave is 3 times 10^8 meters per second. A radio station is broadcasting at a frequency of 10 to the power 6 Hz. find the wavelength. So I got speed, which is v, I got frequency, which is f. They asked me find the wavelength, which is lambda. How is this tree related in the wave equation? So the wave equation actually is v equals to f lambda. V is 3 times 10 to the power 8. F is 10 to the power 6. Lambda is what I need to find. So lambda is equals to 3 times 10 to the power 8 divided by 10 to the power 6. So I cancel 2. So lambda is actually equals to 300 meters. So the wavelength of this particular radio wave is actually 300 meters. Okay? So that's for question 3. Now let's go on to question 4. So the figure below shows how the speed of two vehicles varies with time as they pass a traffic light. Okay, so this is for a car. This is the car's how the speed varies with time. This is for the lorry. They first ask part A, calculate the distance traveled by the car in the first 30 seconds. So the first 30 seconds is over here. To calculate the distance traveled in such a graph, always take note, okay, if I've got a speed time graph, the distance traveled is actually equals to the area under graph. So what I'm going to do, I'm going to split this graph into two segments. First one over here, I call this region B. Next one over here, I call this region A. So to find the area under the graph, actually I'm taking A plus B. So A is a triangle here. So A is actually a triangle. The height of the triangle is 20. The base of the triangle is 20. B over here, okay, is a rectangle. The base is not 30. The base is actually 30 minus 20. It's actually 10. The height is 20. So half times 20 times 20 plus 10 times 20. So what you're going to get is 200 plus 200, and you're going to get 400 meters. So the distance traveled by the car is actually 400 meters. Now, state the time it takes for the car to reach the same speed as a lorry. So because this is a speed time graph, the lorry is always traveling at 10 meters per second. The question here actually is asking you state the time when the car reach 10 meters per second. So it is at this particular point that the car actually reached 10 meters per second. The time is 10 seconds. So t equals to 10 seconds is the time taken for the car to reach the same speed as the lorry. So this is the end for section A. For section B, I hope we have done all the questions. If not, okay, you can take down the answers to some of the questions I'm doing. Okay, the object of a mass 1.4 kg rests on the horizontal surface. An object is pulled to the left by 12 Newton on the left side and right by a force of 5 Newton. Assume no horizontal force acts on the object, calculate the resultant force. So resultant force actually is just the overall force. So if I've got 12 Newton to the left, 5 Newtons to the right, the overall force you can obviously calculate is 7 Newton. So the resultant force is actually 12 minus 5. Well, you're going to get 7 Newton to the left. So 7.0 Newton, because you need to at least 2 or 3 significant figures. So the direction of the resultant force, it will be to the left. Okay, because the left side got more, so let's see the resultant force is to the left. Calculate the acceleration produced by the resultant force. So I want A, I got F. So what's the formula linking F, A together? Actually, the answer is F equals to ma. So the resultant force is 7.0. The mass is 1.4, and I need to find the acceleration. So 7.0 divided by 1.4 is equals to A. Therefore, A is actually equals to 5.0 meter per second squared. Okay, so I say again, the answer is actually 5.0 meter per second squared. Now, in part B, it says, in an actual situation, the object accelerates from rest. So from rest means starts, means the starting speed is equals to 0 meter per second. It reaches a speed of 8 meter per second in 2 seconds. Calculate the actual acceleration. So we know that to find acceleration, we need to take the final speed minus the initial speed divided by the time taken. So if it starts from rest, means the u is equal to 0. We know the final speed is 8, and the time taken is 2 seconds. So you realize I substitute the value here. So remember, v is the final speed, u is the starting speed, t is the time taken for it to reach the final speed. So based on this, you realize a is equals to 4.0 meter per second squared. So acceleration, 4.0 meter per second squared. So comparing the answer B part 1 and A part 3, state if there's friction acting on the object. Now you realize if there's only these two forces acting like this, the acceleration is 5. However, in the actual scenario, the acceleration is only 4. So why is it not accelerating as much? The answer is because there is friction. So comparing state if there's friction, yes, there is friction. Why is there friction? How do I know? As the actual acceleration is smaller. Okay, so actually friction is the one that caused the resultant force to be smaller. And when the resultant force is smaller, it actually causes the actual acceleration to be smaller. Okay, so that's for part 2. Now let's go on to question 6. The graph below shows a heating curve of a solid. So I start off as a solid. Okay, this is a heating curve of a solid. Now ask you identify the states of matter for the following sections. So let's draw the following, let's break it down into the following segments. So I got 1, 2, 3, 4. Now, in this kind of graph, first thing you need to know is that when the temperature is changing, there's no change in state. So change in temp equals no change in state. And then when there's no change in temperature, that means there is a change in state. So this one is to help us to decipher the graph. So at this point A to B, you realize there's a change in temperature. So there's no change in state. So if I start a solid at this point here, obviously it will only be solid. From B to C, there's no change in temperature. Temperature remains at 25. So I know the state is changing. So solid change state, that means this is actually the process of melting. When it's melting, okay, what you're going to have is you have two different states present. So I got both solid and liquid over here. At part C, you realize the temperature starts to increase. There's no more change in state. So what's happening is that at point C, the solid has fully melted and it has fully become a liquid. So from C to D, it's only liquid. And lastly, D to E, the liquid is actually changing state. So at this point, actually it's boiling. So when it's changing state, you actually have two states here. You have both liquid and gas. So based on this, all this that we have interpreted, yes. Identify the state or states of matter in the following section. So A to B mentioned only solid. B to C is melting, so I got both solid and liquid. C to D is just purely liquid. D to E is boiling. This is a state where we have both liquid plus gas. Okay? State the melting and boiling point of the substance. So the melting point is actually the temperature at which the substance melts. So you look for the flat part. So the melting point is 25 degrees Celsius. The boiling point, so look for the flat part again, is 75 degrees Celsius. Okay, so the melting point and the boiling point is actually a temperature in which a substance changes state. In this case, melting is when it's changing from solid to liquid. Boiling point is when it's changing from liquid to gas. Now, explain the shape of the graph in section D to E. So where is D to E? Over here. So why is it flat? Well, that's actually a key thing here. So the answer to this is actually that heat is absorbed, okay, to break the bonds, okay, between the particles, okay, to break the bonds or to weaken the bonds between particles. Okay, Actually, there's a longer explanation, but because it's only 1 mark, this will be it. Okay, if you want to add on a little bit more, what I can say is that there is no change in the kinetic energy of the particles. So there's no change in average speed of the particles. As such, there's no change in temperature. Okay, so this part here is like a standard statement that you can write down each time when you see the graph is flat and it's changing state. Okay, to be exact, there's no change in the internal kinetic energy. Okay, so that's for part C. Part D, B, C, and DE, which one requires more energy? So BC is melting, DE is boiling. So which one actually requires more energy? The answer actually is DE, which is boiling. Now, why is it so? BC and DE, what's happening at both is that heat is absorbed to break the bonds between the particles, or to overcome the bonds between the particles. So then, if both also to overcome the bonds, how come DE requires more energy? Okay, DE is boiling. Why does it require more energy? Because the energy absorbed is not only used, to break the bonds. Okay, it is also used to overcome atmospheric pressure. Okay, so there's actually the pressure from the atmosphere pressing the particles down, not allowing it to escape. So that's why the particles absorb a bit more energy to overcome the atmospheric pressure on top of breaking the bond. Okay, next part E. Suggests how boiling point of a substance can be reduced. Okay, so this is actually to add impurities. When you add impurities, you are actually causing the boiling point to vary and to change. So that's for part E. Now, question 7. Figure shows electromagnetic spectrum. So this is the thing. So most of you, I think you have seen the video. There's a song that goes with it. So it goes like sort of radio wave, microwave, infrared, radiation, visible light, ultraviolet, X-ray, gamma ray. Okay, so this is the sequence. So if you look at this whole thing here, obviously before microwave, P is actually your radio wave. After microwave, infrared, visible light. After visible light, what you actually have here is UV. Okay, let's spell it out. It's the ultraviolet radiation. Ultraviolet rays. Okay, so that's for P and Q. State 1 use of microwave. Okay, so it is used to heat up food in microwave ovens. Okay, so some of you just say microwave ovens. I think that's fine, but let's be a bit more specific, huh? Now in part 3, it says state the color you expect to find at region M of the visible spectrum. So M is on this end, N is on the other end. Now I just need you to take note. Q is actually your ultraviolet. Okay, so in the visible light spectrum, M is closer to infrared. So actually M, the color you expect is red. For N is closer to the region of ultraviolet, so I would expect the ending spectrum of the visible light to be violet. So in this case, region M, what color would I expect to see? The answer is red. But if they ask for N, then of course the color will be violet. So how do I know red and violet? Look out for the region just before or just after. Okay, that will give you a clue on what colors you should be talking about. Okay, next part B, part 1. Sound waves are longitudinal waves which travels in a series of compression and reflection. What do you understand by the term compression and rarefaction? So idea, okay, sound waves, compressions are actually where the particles are more packed together. because the particles are more packed, so actually compressions are regions of higher pressure because the particles are all packed closer together. Whereas for rarefaction or rarefaction, whatever you pronounce it, they are actually regions of lower pressure. Okay, so just by writing lower and higher pressure, you get 2 marks over there. Okay, so let's look at the next one over here. Sound is captured by a microwave sensor in a data logger. The figure below shows a sound wave captured by the data logger. So you can see here the wave initially looks quite nice and it's a bit wavy, a bit like cricket kind of thing. Okay, so they ask you state the largest period of a sound wave. What is period? It's the time taken for one complete wave. So can you see this is one complete wave? This is also one complete wave. This is also one complete wave. This is also another one complete wave. So the question is, which one give you the largest period? Which means which one give you the highest time taken for one complete wave? Answer is actually this one, 0.040 seconds. Now, hence calculate the lowest pitch. Pitch is actually linked to frequency in sound. How is frequency linked to period? So you remember the formula? Frequency is actually calculated by taking 1 divided by the period. So to find the lowest frequency, okay, lowest pitch will mean the largest period. So therefore I take 1 divided by 0.04. So I say again, lowest pitch or lowest frequency, this also means that it is the highest period or the longest period, whichever you want to use. So 1 divided by 0.04, you're going to get 25 Hertz. So frequency, the units is Hz, which represents Hertz. So the pitch, the lowest pitch is actually at 25 Hertz. So that's the end for the paper. Okay, it's not a very, very difficult paper. Actually, it helps you to consolidate all the topics you've gone through whereas you're doing this paper. It is a relatively good paper to really revise and to think through your concepts. So that's all. Any questions, please feel free to approach your teachers to clarify on it. That's all.